Hey, Mr. Harridan here. We're planning on doing part 2 here of the element compound mixture discussion here. So I'm going to come up with a couple of examples here. So I would say that we have hydrogen. Let's say that we have salt water. Let's say that we have Rocky Road ice cream. And I can't spell Rocky Road ice cream. And let's say that we have iron 3 oxide. Okay? We're going to go through this flowchart and see how these work in here. Can you lift off multiple atoms or compounds in the substance? Hydrogen? No. So that would be an atom. Salt water. Well, there's salt, which is a compound, and water, which is a compound. So that would go under here. Rocky Road ice cream. There's like marshmallows and there's almonds and stuff. I can list multiple stuff. Okay, and iron 3 oxide, there's iron and oxygen, so that will go under here. So now we have separated our element from our compound, homogeneous mixture and heterogeneous mixture. Then we ask the next question here. Are there only elements that are bonded together in a substance? Salt water has salt and water. Those are bonded together, but there has to be only one. So salt water will go over here. Okay. Rocky Road ice cream. Again, we can list multiple parts of Rocky Road ice cream. So that would go over here. And you can't see what I'm writing at all. Awesome. Good job, Mr. Harridan. Professional video maker. Okay. Iron 3 oxide. So I'm listing off iron and oxide. But I'm not listing unbonded stuff, so that would go over here. So now I have found the compound in that selection. Are the substance uniformly mixed? In other words, does it have multiple phases or one phase? Salt water has one phase. So that would go right here under homogeneous mixture. I'm going to write phases here just for fun. Okay. Rocky Road ice cream, well, you can see the marshmallows and you can see the almonds, and it's different than the ice cream, so that would be under here. And that's basically how you go through the flow chart and figure out if it's a homogeneous, heterogeneous compound or element. Thank you. On to page 5. Okay, so here's the comparison charts of the mixtures here. Remember, homogeneous mixtures are solutions. They're the same thing. And there are two types of heterogeneous mixtures, colloids and suspensions. Solutions have the smallest particles that you can't even see. Colloids have medium-sized particles. And suspensions have the largest particles. Do the particles separate over time? The only one that does is suspensions, because the particles are the largest. Okay, for solutions, you can only evaporate to separate. Colloids, you can use evaporation or centrifugation, depending on what the colloid is. And suspensions, you can use filtration, evaporation, and centrifuge, depending on what the actual suspension is. Tyndall Effect, remember this is the scattering of light. The only two that scatter light are colloids and suspensions. Okay. Example, salt water, sugar water, colloids, there's milk, and suspensions will be a vinaigrette salad dressing. Okay. So, what steps would you take to classify something as a solution, colloid, or suspension? Interesting question. Let's see what we're going to say here. Let's start off with suspensions. I would first see if the particles filter or separate out upon standing. Okay. If it is yes, that is a suspension. If it is no, it is either a colloid or a solution. So now I have to figure out the difference between colloids and solutions. Okay, so colloids and solutions here. How am I going to tell the difference here? So I'm going to do the colloid, and I'm going to shine a light through it. Okay. If it scatters, it's a colloid. If it's no scatter, it's a solution. And that's how I would physically test stuff to see if it was a suspension, colloid, or solution here. Okay. For each of the following, indicate if it's an element, compound, homogeneous mixture, or heterogeneous mixture. Here we go. Starting off with air. What do you guys think? Well, air has nitrogen and oxygen that are not chemically bonded in it. Do you see chunks in the air? No. So this would be a homogeneous mixture. Remember that it's also called a solution. Okay. Rust. Well, I know that the formula for rust is Fe2O3. These are elements that are bonded together, so this is a compound. Iced tea. Okay, now we get into the fun part here. Iced tea. If we're talking about iced tea with ice, we're going to put it in the heterogeneous category. Okay. Chicken soup. You can see the chicken, and you can see the soup. Sometimes noodles, if you're lucky. That would be heterogeneous. Dirt. Dirt has soil, twigs, rocks, and I can see different phases in it. So that would be heterogeneous. Chlorine. Chlorine has a formula of Cl2. This is one element. There's not two listed here, so this, and you can find it on the periodic table, so this is an element. Sugar. I know the formula for sugar is C6H12O6. That is a compound. Gasoline, okay, is octane in different hydrocarbons, okay, and there's no chunks in gasoline, so we're going to put that under the homogeneous mixture part. Filtered pure water. Okay, if we're just talking about water. Just pure H2O. This is a compound. Keyword here is pured and filtered. Okay. Hydrogen. Symbol for hydrogen is H2. That is found on the periodic table, H's. So that is an element. On to the next column. Ketchup. Okay, ketchup's a tricky one. You would think it's homogeneous, but it is actually heterogeneous. This is a colloid. Okay. Granite rock. You can see like the little white and black chunks in it, and they're mixed up. So we're going to put that as heterogeneous. Orange juice. Okay. If it has pulp, we're going to put that in the heterogeneous category. Sodium chloride. Formula for sodium chloride is NaCl. These are two elements that are bonded together. This will be a compound. Baking soda. The formula for baking soda is NaHCO3. Nacho 3. Compound. Oxygen. Oxygen would be O2. That is an element. Sugar water. Well, sugar is C6H12O6, and water is H2O. So we've already listed two different things here. Okay, so that is a mixture. Does sugar water look chunky? No, it does not. I can't see the chunks in sugar water, so that will be homogeneous. And remember, another word for homogeneous is solution. That's correct. Okay. Concrete. You can see, I think that's a mixture of sand and calcium sulfate or something. I don't know why I don't build houses usually. So that will be heterogeneous. Carbon dioxide. I know the formula of that would be CO2. And that would be a compound. And then finally, aluminum, which is on the periodic table, it's listed as Al. That's an element. So you know. Okay. You guys are champions. The legend is out.
That was easy.
Yes, it was.